In this block, we are going to talk about the arrhythmias that due to conduction abnormalities. First, we are going to summarize the general information about the conduction. Conduction abnormalities can be two types. When we do have a slower conduction, these called blocks, or we do have a faster conduction, mainly between the atrium and the ventricle by bypassing the AV junction, and these are called pre-excitation syndromes. Let's concentrate first on the blocks. The blocks can be a grade based on the severity. The mildest one that's called grade 1 or first degree, or grade 2 as second degree, or grade 3 as a third degree blocks. By location, we do have three different compartments when we do have some preferential conduction system, such as the sinoatrial node and the atrium. We do have the AV junction that is located between the atrium and the ventricle, and intraventrically when we do have the bundle branches. When we are going to talk about the pre-excitation syndromes, we are going to talk about the Wolff-Parkinson-White syndrome and the Long-Gannon-Levine syndrome. The type of blocks. When we do examine a connection between 2 points A and B, we are going to evaluate how fast the depolarization is spread from A to B. Normally, this takes a certain time. We know that, for example, the AV junction, we do have a connection between the atrium and the ventricle when the PR interval is ranging from 0.12 to 0.2. This is the normal range. However, when we do have a first degree block, we still have a connection between these 2 points, between A and B. However, the depolarization spread slower from A to B, but every impulse is getting from A to B. The second degree block, that usually we do have a pretty good connection between A and B. However, sometimes the depolarization that starting in A cannot get into B, so we do have some dropped beat. We cannot have more than only one drop P or dropped beat between two conducted beats. The second degree blocks can be specified as Mobius type 1 or Mobius type 2. Mobius type 1 means the speed of conduction is gradually worsening after we do have a drop beat, and the last conduction time is longer than the first conduction one. So gradually slowing down the depolarization, how it's spread. And once we do have a drop beat, after this depolarization spread with the same velocity as at the beginning. Usually this type of block is regularly repeated. We can have, for example, as here we do see 4 to 3 conduction. Mobius type 2, opposite to Mobius type 1, the speed of conduction doesn't change. Whenever the conduction is spread from A to B, the speed is the same. And after we do have a drop beat, and after continuing the conduction again. So normally conducted or dropped, conducted, dropped, conducted. 2 to 1 blocks. In this case, we do have the highest degree of the second degree block because every second beat is not conducted or every second beat is conducted. It cannot be differentiated using a 12-lead ECG from Mobius type 1 from Mobius type 2. So spreading, not spreading, not spreading, not. That can be rhythmic. High degree blocks, meaning that there are more non-conducted beats than conducted one. So the connection between A and B is rare or very lost. not conducted, not conducted, and we do have still some connection between A and B, that meaning we do have connection. Make a note. If we have mostly unconducted beat, a lower center, pacemaker center, is going to generate an escape rhythm. So when we do have this unconduction, we do have the escape rhythm, making this is rhythmic. And when we do have this conducted bit, that makes it arrhythmic when we do have a conduction through this A and B, and that's called capture bit. There's another possibility when a capture bit and an escape bit activates together that compartment, and that's called fusion bit. So in the case of high degree blocks, this is arrhythmic. We do have three types of uh, depolarization. One, that the escape center is activated, and other one, a captured bit that goes through this conduction pathways, and another one when together the escape and the capture bit activates the compartment, and that's called fusion bit. Third degree blocks means there is no connection forever between these 2 points, and of course the patient can survive only if the escape center is going to fire and taking over the impulse formation. So none of the bit is getting from A to B. When we are going to evaluate these conduction abnormalities, we do have three compartments. We do have the assay, so we are going to evaluate the conduction between the assay node and the atrium. It's only one problem, that the assay activation does not have any sign on the 12D ECG. Only what we can see, and that's the atrial activation that represented as a P wave. AV blocks that very good because in this case we do have a sign of A as a P wave, the atrial activation, and we do have a sign as a ventricular activation as the QRS complex. So we are going to evaluate the connection between these 2 points. So this should be the PR interval in our case. Intraventrically, when we do have the bundles, these bundles can be blocked or can be uh, take the charge slower. And whatever is going to be altered, that usually the QRS complex, the width of the QRS complex and the shape of the QRS complex.